welcome to our first podcast show, in fact. And you're so lucky to be the first one here, or you're probably the 30th one here. So you're welcome to our podcast show where we, of course, tag the African Data Scientist. The African Data Scientist is a podcast for budding African data scientists hosted by the Port Harcourt School of AI. And this is one of the programs, Insights in AI and Data Science is one of the programs we hold where we get to talk to practitioners nationally and internationally, both Nigeria and away from Nigeria, on their thoughts on artificial intelligence, data science, as well as some career tips they may have for viewers along the way. So for this week, we're going to be welcoming Vangelis Oden. So Vangelis Oden is a data and machine intelligence engineer at Indicina, a fintech startup that provides smart services for their clients. So I'm so glad to have Vangelis here today. Vangelis, welcome.
Hi, everybody. Good evening. Welcome to this program. Yep.
Awesome. So before, if you don't know before now, of course, you probably must have heard an episode before now, but Insight in AI is actually a program offered by Port Harcourt School of AI. We get to pick the brains and the minds of, not pick the minds per se, but get to know our guests and get to know practitioners in the space and see how their thoughts on artificial intelligence, data science, and everything going forward. So we're going to be having a conversation with Evangelist today, and I hope you enjoy this. Yeah. So yeah, Evangelist, welcome once again. Please, can
Thank
you
you.
start by introducing yourself?
Okay. My name is Vangelis Michael Oden. I hold a BSc in Electrical Electronics Engineering from the University of Port Harcourt. Choba. Yeah. And then I hold two master's degrees in both data science and machine intelligence. Currently based in Rwanda, but work for a fintech startup in Nigeria, Indicina Technologies, and basically I work there as a data and machine intelligence engineer, where I basically design cool stuff for the company. Yeah, that's basically me right now. I would say I'm really down to earth, really cool when it
I can
comes
testify.
to having having discussions. I'm basically up for all for designing solutions, building things from scratch, and really seeing them affect people's lives. Basically, that's why I went into engineering, to be able to build solutions that can scale to lots of people, and that can use model solutions, new technology, and all of that. I'm crazy about new technology. Yeah. So that's me in a nutshell.
That's awesome. That's a very, very awesome introduction. Thank you, Evangelist. So, well, typically, what did you want to be when you went to college? Did you get into college with the mindset that, oh, I really want to solve problems with engineering, or, you just wanted to be one thing and you ended up studying another thing? What was that experience like?
So, getting to the university, before the university, I always just wanted to um, break down break down problems and solve them, or break
Hmm.
down systems rather and solve them. So I was more interested in um, computer engineering. I was interested in ethical hacking. No, not
Okay.
necessarily ethical hacking,
Yeah.
in general.
Oh, yeah,
Yeah,
yeah.
really interested in those areas. Basically, being able to take the system, break it down, fix it, return it to the previous state, exploit systems.
Hmm.
And at the time, I needed to find really good courses that could help me get my head around this. And yeah, the obvious choice would have been computer science. But I just believed and felt for some reason that I could not really learn computer science to the capacity and level I really wanted to in Nigeria. So I decided the next best option would be electrical electronics engineering. I mean, it was still close to a possible, a future goal of mine, which is um, robotics and helping computers think. And I found that at some point I really enjoyed some of my best courses, control engineering while in undergraduate, and I just enjoyed the ability to give logic to a system and watch it perform just that logic, and that helped me start gaining the intuition on how to teach computers to learn, not just teach them to act, but teach them to learn how
Mm,
to act.
mm.
Yeah. And so, yep, that's basically my flow through why I decided to pick electrical electronics engineering as a course. Yeah.
Oh,
Um,
okay. Hmm.
yeah, going further after, based on the environment I was, based on the Port Harcourt environment,
Yeah.
uh, I the next option would have been to employ these skills in the oil and gas sector, and yeah, stay in maybe Shell or Chevron or one of those places and just build systems or work with the systems they have available. But I decided to take it a little bit further and just to something more challenging, since I always felt that these systems have already been developed, have already been built, and I needed to get into an area or specialization where I'll be building the solutions from scratch to finish. So that was one of the reasons why I moved away from Port Harcourt, away from oil and gas, away from more of the more of the setup, already set up systems,
Hmm.
to an area where I could build solutions from the ground up. Yeah.
Mm, all
So
right,
that's
that's awesome. That's awesome. Generally, the journey has been exceptional, and in fact, it's as though you've been very intentional about this from the start, from your getting into the university right through to where you are currently. Which
yeah,
speaks a lot
yeah.
of volume. Thank you so much. So, I'm very curious. Of course, you've mentioned how you became interested in artificial intelligence, but were there key moments that spoiled your interest? Maybe you probably didn't know about, deep learning, artificial intelligence, machine learning from the onset. What were the key moments that spoiled your interest in this field?
So first of all, I'm a very huge fan of sci-fi movies. I
Yeah,
love
yeah.
sci-fi
Like all our
movies.
guests in the past, yes.
Yeah, but yeah, when you rapidly get into the deep learning AI field, you'd find that a lot of those movies are just a whole bunch of mumbo jumbo. But yeah, cool. Most of the movies I was watching at the time helped open my eyes to what could be possible. So it was not really about what the movies were doing, but what the possibilities that laid in this untapped area of data. So yeah, that was basic. That those watching those movies at the time, like iRobot,
Yeah,
with
Isaac
Will Smith,
Asimov.
the one with yes, those were the movies that really just tuned me to this direction. Otherwise, it was basically me speaking with a couple of mentors to understand
Mm,
where technology was headed at the time. I needed to, having graduated from the university, I needed to understand my place. What was I going to be doing? Was I going to be an inventor? Was I going to be someone who was building things? Was I going to be someone who was just implementing? Was I going to be someone that was researching? And after speaking with a couple of mentors to understand where technology was headed, what was going to be the next frontier in terms of
mm.
technology, I was then able to decide that, yeah, okay, it was worth a chance giving it would be worth it giving data a chance, and how, based on how untapped the resources were. Yeah.
Yeah, that's really an awesome inflection point. Like pretty much almost 80% of all guests from our show has always said, "Oh, it's sci-fi that has really brought me into this," because having to transfer such passion for what could be and turn them into engineering problems that can be solved and be what should be per se is one of the key reasons why they got into the field of deep learning and thinking machines, which is really awesome. So I think we can move on away from having those personal questions now and to more related machine learning, data science related questions. So there's this question we ask most of our speakers. So pretend I'm not a tech person or a data scientist. So, well, can you explain what machine learning, data science, those terms are in simple terms for me?
Hmm. Okay. How would I put it now in very, very layman terms? Okay, so I'll do that. I'll explain this by giving an example. I think a friend of mine actually used this once. So let's I'll pose a rhetorical question and you can answer it or not answer if you don't want to. So an example: if I say all politicians are corrupt.
I would say yes.
No. I'm not asking you now. I'm not asking you. I'm just saying now. All
Yeah.
politicians are corrupt. Obama is a politician. Therefore, he is.
Corrupt.
I didn't say he's corrupt. You're the one that said it.
Yeah.
Anyways, that is a generalization. That is
Yeah.
a generalization you have been able to make based on a simple fact that you have gotten to know over time.
Mhm.
Machine learning and deep learning, data science is the science of understanding facts that have happened over time and
Mhm.
using these facts to generalize on a new concept or on a new explanation or on a new theory in future, right? That I believe should be like the most layman explanation of how of what machine learning is, of how what deep learning, what um, um, data science
Data
is really
science.
doing.
Mm.
You're taking old data, historical data, facts that have happened, inference that you've been able to draw from the past, and using that inference to predict a future case, to describe a future scenario. And based on that, you can draw inference over any particular problem from classification to prediction of time variant quantities to prediction of um, continuous variant quantities
Yeah.
and also to
Mhm.
prediction of discrete variant quantities.
Yeah, it's probably perhaps one of the most unique takes from this time we started the episode. This is of course episode 7, so
Oh
it's
wow!
one of the
Okay.
most unique takes from this particular question. But in your words, how do you think these particular fields? I'm trying to of course separate data science and machine learning. How do you think they aid problem solving?
So right now, the use of data aids problem solving in several ways. So one might always think when they're getting into data science that they're getting into just predict things happening. But I have rapidly seen that most of the data science that is being done in large organizations, even in small organizations, just relies on an ability to understand what the data is saying concerning any particular problem and just being able to make decisions out of it. So for instance, let's take for instance a loan company that lends out to customers. Yeah, one of the many interesting things that can be done is to build credit scoring models that
Yeah.
can try to predict default for a customer. But then another part of using the data could be just to understand how users interact with your application forms and if they're completing your applications. Another use of data science could now be to rearrange your application forms such that people can apply in the shortest possible time. 3 seconds to 3 minutes of an application. Do I have to apply for a loan in 24 hours, for 24 hours? Or can I do that in 3 minutes? How would I know that? I don't need to do any prediction modeling or all of that. I just need to look at the data, based on how people have been interacting
Yeah.
with the
Mhm.
application forms, maybe online,
Yeah.
either maybe through the web or a mobile device, and see where maybe they drop off a lot more because they don't understand they don't understand what's really happening at that particular place. So I can build a better workflow for them based on data, right?
Mm.
So data science encompasses all of the analytics, just looking through data and understanding patterns, to the machine learning using statistical models to try to predict or describe data, to the deep learning AI stuff part where you are now dealing with more different data variant of types, right?
Mm.
So
Yeah.
all of these different fields form up what is the main area of data science. And for anybody, you can get into any of these areas and really excel in any of them.
Yeah, that's a wonderful take on the very very broad areas of where data science can actually aid solving problems from the large scale to the small scale businesses or commercial applications per se. And I think it's a brilliant take. Or now you've of course made it clear. You've made data science and machine learning clear to the audience, to the listeners. But typically, what's one thing about data science that or machine learning that you think is clear to you but it's really not clear to anybody else, whether they are non-engineers or engineers? What's that one thing that you think is clear to you?
Yeah, so a lot of people feel that when they get into data science, more of the work is going to be around building world-class models and designing really robust deep learning systems. But in reality, most of the work centers around pre-processing data.
Mm.
The truth of the matter really is you are going to spend 90%, 80 to 90% of your time pre-processing data, trying to understand different data types. So when you do a lot of MOOCs, that's massive online open courseware,
Moocs, yeah. Hmm.
they basically give you a lot of cleaned data for you to do minute cleaning and get stuff done quickly. But in the real world, in the real problems, sourcing your own data is where is an issue. When you get your own data, understanding if that data is even useful for the problem you're trying to solve is another issue. When you finally understood that data, pre-processing and cleaning it up to fit the kind of problem you're trying to solve is another issue. There is no standard. There are no standards. There are only hints as to what you can particularly do, particular steps that you could take and try out. But there is no standard to this is what you should do, right? So
Yeah.
you then get to formulate how you are going to approach each problem. You get to formulate how you're going to approach each data point, each data set you have access to or need to have access to. And that's the most interesting part of data science. That's the most interesting part of machine learning. That's the most interesting part of deep learning. Understanding the data. Once you can understand your data, once you can wrangle, pre-process, move your data in different dimensions, then building a model is really an easy task, I'd say. All you need to do is maybe read up a couple of papers on an implementation based on the problem you're trying to solve, and very quickly you should be able to have a working solution. But many of the times, on a data science project, possibly you can spend almost a month on data pre-processing before you even get to
Yeah.
spend maybe a day or two on model building.
Okay, that's a really wonderful approach to the thing because yes, a lot of people are always in the delusion that yes, it's all going to be about building those world class models like you said. But coming to think of that, in fact, there are a lot of tools that actually automates the model building processes, but not so many can automate the data processing,
Yeah.
pre-processing, side of things, which is actually one thing I think most individuals and organizations alike should take note of, and that's a wonderful thing. So, um, I know you've, of course, you have lots of experience. Of course, you've gone through your masters and you're now working in the industry with in the China. That's the fintech industry, of course. So, how would you advise a small company to adopt an AI strategy? What do you think they will need to be successful at doing for AI and data science for them to successfully apply AI and data science in their businesses?
So yeah, a lot of companies feel that oh, because there's AI and data science, we must jump into it. We must start doing AI and data science. And I've spoken with a couple of founders, recent founders and entrepreneurs who have just started up companies and are looking to start incorporating data science. And more of my advice at the early stages is always um, build kick-ass logic systems. If you can build kick-ass logic systems, of that's logic systems, when I say systems, I just mean massive if statements
Mm, yeah.
that will try to just get things started. If you can build massive logic systems, then after some time, you then grow into that AI capability where you can then start building AI systems. If you have, if your problem, if your task, if your what you're looking at cannot be built as a logic system, then you cannot successfully say that you can model it as a data science problem or as an ML problem. So I always tell a lot of some of the founders I talk with, build logic systems, build robust systems, think towards the future, how you want what you want the data science team to look like, what you want the data science capabilities of the company to look like, and start building those capabilities before you get there. Because once you get there, if you did not build it before then you have issues with overhauling systems. And this is one of the issues we have with many of the commercial banks in Nigeria. They did not optimize for the science of data. They optimized for maybe business intelligence, but not the science of data. So now they are seeing themselves in a data science world, in an AI fast driven world, and they can't adapt very quickly because they have these systems that they had built for old business intelligence
Dynamic
methodologies.
enough.
And yes, and the AI world now needs really fast, rapid systems to move decisions as quick as possible. Um, Data is as good as useless if it is not being analyzed in the right way, the right time, and presented to the right people in authority. So yeah, I always advise build for where you're going to, create
Mm,
the
okay.
systems in
Mm,
time, arrange your platform till you get there. And that's one of the beautiful things with Indochina. We have systems in place before we even had AI.
mm,
We were using platforms before we even started talking about data science. And even till now, we still try to automate some of the processes using logic systems for our clients, so that when it's time for AI, machine learning, they will be ready before they would have been ready right before that time, and they would easily be able to plug into whatever solutions we'll have available at the time.
Absolutely. I really love the take of going from traditional BI logic systems, that's traditional logic systems, to graduating to a more machine learning driven approach to solving problems. And it all starts with, can this of course be solved by logic? Of course, like you rightfully claim, if it can be solved by logic, of course you can possibly apply an AI strategies to them. And one thing, of course, I'll add is all about conducting that needs analysis as well. Do you think this problem
Yes,
should be
exactly.
solved by AI? If it's most likely not, you most likely not need AI to solve this particular problem. But graduating on to something, I think, of course, because good software companies are going to be ones that are going to be data driven. So, but
Yes.
how would you advise small African companies, the African area of African sector where we are starting off to develop a proper data strategy, maybe a data collection strategy for them to prepare for a more data-driven AI-powered future. How would you advise them to go around that?
So I love one of the I love Google's model of data collection, data warehousing, data,
Yeah. Hmm.
and basically the tools available from Google or by Google for
Hmm.
this use. I think Amazon is trying to build the same model, but I prefer Google's model because and I'm not advertising for Google here.
Yeah.
I just prefer using their systems, right? I think they're more optimized for startup companies and how startup companies can rapidly start getting analytics out of maybe their applications or whatever their systems are. Speaking with the CEO of Farms to You, she she is her company is a startup. All she has is an application and a process around an application that's supposed to help farmers in um, sub-Saharan Africa, and
Yeah.
she simply just plugs her applications through to the Google Analytics system, and that helps her draw insights rather rapidly from how her application is being interfaced with, who is interfacing with her applications.
Hmm.
So yeah, it's pretty much an easy thing to get set up with, and anybody can actually just Google how to move data through Google platform, Google Cloud platform, right, from an application
Hmm.
to
Yeah.
Google Cloud platform, and it's rather really simple to walk through. However, if you want to still build some more on-premise systems, then yeah, that's still left to your pockets, if you have the money. But then Google's platforms now, you get to be charged not by how much data you store, but how many times you query your data, how many times you get access to your data.
Hmm.
So they
Yeah.
tell you store the data with us, no problems, no qualms, no money paid. But when you have to extract that data, we then charge you a very little fee for how you extract the data, and that's how they make money from it. So it keeps me not worrying about the volume of my data.
Yeah.
I don't
Yeah.
want to worry about the volume. I just want to keep my head around the quality of the data, and how it's entering whatever storage buckets it's entering, and then how I'm able to make sense out of that data.
Hmm.
I
Yeah.
don't need to care about how much of the data is coming in, right?
Hmm.
So yeah,
Yeah.
as a startup, you don't want to be caring much about the volume. You just want to care about the value of the data, the quality of the data, the veracity of the data, um, yeah, and stay around those particular metrics first of all.
I absolutely love the idea of using Google tools, and of course, not Google isn't a sponsor of this podcast yet, or
Yeah,
anything. Not that we endorse on their technology, but I actually personally have been using Google Cloud Platform for my for most of the job I do, and things like having to support small businesses from um 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 ML, that's ML right on the go. That's their BigQuery ML service that
yeah,
really allows you to do fast insights, at least from the basic level, and helps you store data at such unprecedented rates per se, and query data and get analytics right on the go, which is a really, really fascinating thing for, I think, for startups. And maybe this is a controversial take, but on-premise systems are fading away. Cloud
yes,
security is
exactly.
becoming a really rapidly advanced thing now. So you don't really have to care about data security anymore, because the cloud vendors are most likely going to handle all of those for you. So as much as startups getting started in this space, looking at cloud systems for most of their data strategies, and that and all of those things is actually one thing I would also recommend, just in addition to your amazing opinion there. All right, so
Yeah,
going on,
totally.
yeah, so going on to the next question is more about the challenges you face, when you started out in this field. What challenges did you face, and how did you overcome them? What were the challenges you came about?
So for me, becoming a data scientist in Nigeria was really, really, really difficult because At the initial time, nobody was doing data science in Nigeria.
Mm, okay.
A couple of people were doing analytics, but nobody was doing data science. Like data science, I'm talking about when I say data science, I mean machine learning, I mean deep learning and all of that. And those were the deep areas I really wanted to go into. I wanted to understand how to classify images, how I could make inference from language,
Mm,
from
yeah.
sentences, from speech. I wanted to understand how to design new photographs of images of human beings that don't exist based on images of human beings that exist,
Hmm.
and scale all of those solutions to how I'm able to understand fraud, how I'm able to predict customer behavior, how
Yeah.
I'm able to build chatbots, automated chatbots. So growing in Nigeria was a little bit troublesome because
Hmm.
there was nobody. But luckily, at some point, the organization Data Science Nigeria came up, and I attended a boot camp there, and I went to the boot camp and was just shocked at
What year? What year was
how
that?
much this was 2017,
Mm, okay.
ending of 2017, and I was just shocked at how much there was to know. I had already done a couple of courses in big data analytics, moving and analyzing data, and I understood that from that perspective, but I did not know where I was to go from there, and that's what always very key. Knowing what's next,
What's
knowing what
next?
you
Yeah.
should learn next, what you
Hmm.
should do next is always key to how you're able to grow. And after I saw what was happening or what happened at Data Science Nigeria, I knew where my next target was. I knew what my next target was. So I just kept firing in those directions. I just kept firing in the directions of my next target. I knew I wanted to do machine learning. I knew with enough time, with enough skill, I could um, understand how to analyze data, how to look at data, how to identify patterns in data. Well, that was inherent from also being an artist, but I knew I did not understand what algorithm to use for a particular problem,
Hmm.
how to
Yeah.
tweak that particular algorithm to give you the best results, and what advanced methodologies one could use. How do you deploy those solutions? How do you maintain the solutions after they've been deployed? Those were the things I needed to understand, um, and add to my arsenal of knowledge. So yeah, I after Data Science Nigeria in 2017, I just kept firing in different directions. Joined my first real data science job in 2017, and from there it just went on. Once you're able to in the field now, being able to tackle real data science problems, real ML problems, and see how they affect business, being able to monitor the life cycle of the models. So a lot of the times people just think, oh, okay, yeah, you've built a model that has 90% accuracy. Yay. How does that 90% accuracy translate to a business? How
Hmm.
does it
Yeah.
translate to profits in a company? How does it translate to risk management at the end
Hmm.
of the day? And understanding all of those things, the whole big picture, the total picture of all of that was what I really wanted, was what I was looking for. And so staying at One Finance and Investment for some time, then joining KPMG and finally Ran Money before leaving to Indichina. That has basically been my growth over the years.
Oh, that's a really awesome experience, and of course, to laud the amazing efforts of Data Science Nigeria as an organization. Like I would always say, the highest impact technology nonprofit in Africa, and
Yeah, exactly.
how they've managed to shape a lot of careers in data science, and all props to, of course, Dr. Bayo and his team as well, doing an amazing job for not just the country but in the entire nation, and of course globally. And in such massive scale as well, which is quite important. But yeah, talking about skills and qualities, what qualities do you think, are the most important for, someone to be a very good machine learning engineer, just like you? What qualities do you think they should have?
So one of the most important skills is your analytical skills.
Hmm. Okay.
You have to be able to analyze systems. Before you jump into machine learning, you have to understand where is the data coming from, where is it going to, before I start building the models I want to try to build. And then what type of model am I trying to build or work with? And how do I possess that system to give me the best results?
Hmm. Hmm.
So you have to be extremely analytical and creative in your thinking around these things.
Hmm.
Um, Once you can understand and the analysis, and you're creative enough to put together the solution, the next thing is your programming and debugging skills. I Your programming and debugging skills have to be top notch. You can't even play with that, because you are going to experience bugs from hell, bugs from heaven, bugs from
Yeah.
everywhere on different areas of your system, from the programming to the deployment um, to the refactoring and all of that. And if you do not understand what language you're using, particularly, and how to think like a scientist, how to identify your problems, then you will always find yourself most likely on maybe Stack Overflow or on Google.
Yeah.
And God helps you the day you don't have internet. So yeah, you have to understand. You have to your programming and debugging skills have to be top notch. Yeah, then you many of the times as a okay, yeah, so I think this still falls into analytical and creative thinking, because many of the times a lot of people see us on computers and think we spend our whole lives on the computers, typing away at code and stuff. But many of the times the main work happens in our heads, where we have to actually just sit down and think.
Yeah.
Just sit down and think about the problem. Sometimes it comes down to writing, having to use pen and paper just to pen down thoughts on how a whole system should run from start to end. But in the end, those are the three main skills: the analytical thinking, the creative thinking, and your programming debugging skills. Those are the three main skills. Of course, other skills come around,
Hmm.
soft skills,
Yeah. Hmm.
the, around the job that you're doing and your role in the particular job, your leadership, team building skills, being able to work with a software engineer and being able to still work with an analyst, and then being able to work with someone who has no knowledge of what you're trying to build and how it integrates with any solution. So yeah, your negotiation skills,
Yeah.
your team building skills, and leadership skills. Yeah.
I think those are important. And one skill that you most importantly mentioned is the scientific thinking, and
Yeah.
having to craft out those hypotheses and find ways to make sure that you prove those hypotheses wrong. That scientific side of things is one thing I see a lot of machine learning engineers ignore a lot because
Yeah.
they're more just let's hack away things, and I'm sure this will work. But in fact, models don't often work.
Yeah. Yeah.
That's the entire narrative about them. All models are
Mm.
wrong, but some are useful. It's just a talk about, and it's just I think that was George, statistician then. So that scientific thinking is one thing I know for sure that the people should learn. And scientific thinking is of course gotten from your years of questioning, asking a lot of great questions,
Yes. Yeah.
about your approaches to things, making sure that your assumptions are always clarified, and all of those things, which is quite crucial for.
Exactly. A data scientist is a questionnaire. You
Yeah.
ask questions until they nearly want to shoot your brain out.
Yeah.
You keep asking even more questions
Mhm.
after they have shut your brain out.
Yeah.
Yeah, until the solution goes out. Because the truth is you are not a product leader.
Yeah.
You are a product follower. You are more like a support in any product. So you
Mm.
need to ask all the questions possible as to how that particular solution you're building helps improve things in the long run, right? Improves things in the long run. So you are always asking questions. You're always inquisitive as to systems, as to data, as to processes. Yeah, you always just want to know everything.
Absolutely. Thank you so much for that take. So leads me to another very crucial question because of course we say this is we call the name of this podcast the African data scientist. We want to make sure we tell the stories of the African data and AI potential. So of course Nigeria is one of the countries in Africa. And how do you think generally machine learning can help developing countries like Nigeria and most African countries? How do you think these countries that are developing in their growth and GDP stages, leverage this machine learning and AI technology for better GDP growth?
Well, so first of all, I feel the only way we can leverage this is first of all by accepting that this is a viable solution to
Mm,
some of our problems. So before software engineering became a rave in Africa and all of that, we wouldn't really or readily accept these systems because we wouldn't not many people would trust this system. So for instance, the man in the village would prefer to hide his money in a pot, would prefer
yeah.
to keep his money where nobody would see it. For him, that's hiding the money. And one of the reasons would possibly be because he doesn't have access to a banking solution. He doesn't have access to maybe a physical bank. Where he stays is too remote from the bank. But with software engineering, and the Internet of Things came to bring or bridge that gap,
Yeah.
allowing people in remote communities have access to bank accounts in urban cities, bank accounts with banks in urban cities, and so the bank in the city can just host an application, and anybody can connect, create a bank account, and log into his bank account whenever he wants to. So the system started getting accepted. People started accepting this kind of systems where, oh, you could bank on the internet.
Yeah.
And of course, the reliability came. People started relying on those kind of systems also. Now, AI, artificial intelligence, a lot of people are still too skeptical about it. Governments are still too skeptical. Like, how can you tell me you can predict the future? That sounds fishy, right? But of course, truthfully, the statistical methods have shown us that with enough historical data, you can tell at least with a level of confidence about a future occurrence. So once governments are able to understand that this system is not necessarily um, bad and can actually be used for a lot of good to predict a lot of scenarios, a lot of situations that would possibly happen in the future, and then start taking proactive measures towards either mitigating those scenarios, those if
Yeah.
for the wrong ones, or embracing or building more robust systems um, to utilize positive results of the predictions. Then we would see a lot more of the AI movement and how AI would flourish in Africa as a whole. I always take example from China, how China has moved their society to a very AI dependent society, such that you can just walk into a shop without money and buy anything you want to buy. Just pick anything and just step out of the shop, and automatically you're credited based on the system's ability to understand um, who you are, your face, give you a social score, and give you access to various facilities based on the kind of data the, the government already is tracking and the kind of solutions they're already building. So I feel, first of all, the government will have to get down into accepting these systems where they see them. So
mm,
I bring an application and say, oh yeah, I have this application that can do this in agriculture, and it's AI dependent. It should not be looked down on. It should not be over scrutinized because it is AI. Yes, the right levels of checks should be done, but it should not be looked down on because it's AI, right? And it's a probabilistic thing, right? So that's my first take. That yeah, governments have to look into stuff into it. Second is AI can be done by anybody, right? It's not restricted to some super brainy guys in
yeah.
MIT or Harvard
Mm-hmm.
University. AI can be done by anybody. There are different areas and spectrums of the whole data science field that anybody can plug into. You can plug into just analyzing data, just an ability to use statistical techniques to understand what data is. You can just develop AI applications as simple on the internet now. You have all the resources. So the thinking or feeling that AI should be restricted or is restricted to some people, for some spectacular people, first classes, and all of that is definitely an off an off putting, right? I would employ I would join or employ anybody who
Yeah.
is really interested in how to build systems that can understand data to just go ahead and start building. Go ahead and start building. Learn the math as you're going. Learn the code as you're going, and just start thinking systems and building. The more people will have in the area building systems, the more an ability to expand the field of AI, expand the algorithms available, expand the methods available, and that's why I'm happy. I was very happy for one of the, for the my the masters in machine intelligence. It was designed for Africans by Africans,
Yeah.
right? It was designed to help Africans understand that AI is dependent on data. The data bias, you can't import a model from the US, or rather you can now, but yeah, it makes no sense, or it should make better sense to build systems for Africa than just importing the systems from the US, from the UK, from China, and using and then trying to make those systems work on our data. We should be able to build our own systems based on our own data. So that means everybody's hand should be on deck. Everybody should be interested in data gathering. You can start up a small company that revolves around gathering data for different types of different purposes, for
Mm,
image
yeah.
capture, for data analysis, for
Mm-hmm.
sound and audio,
Yeah.
for text. You can start up your own company doing that. And trust me, a lot of companies are ready to buy your data. They're ready to buy the kind of data you have available to use for whatever systems they have to build, because that will make them more money, right? So there is a whole lot of things that can be done, and I employ anybody, everybody, anybody, both young, old, small,
Yeah.
intermediate,
All
zero
ranges.
knowledge, to just get in. Yeah, just get in. Get your hands busy with something. Just get your hands busy with something. The field is vast, and you'll be able to make it anywhere or anyhow you choose.
Mm. You're getting it. That's a fascinating take. And just to draw from your first point, it's one of my most favorite quotes. Enough of history can tell us about the future. That's one
Yeah,
thing I definitely know for sure. Anything that's happening in the future has most likely probably happened sometime in the historical and transient of things. So that's a really wonderful take for when it comes to we the government and necessary bodies leveraging this technology and we should assume we're in the parallel universe now. I'm not trying to just go through, and they start leveraging these technologies. Let's say, what would you think? Like, what's your thoughts on the future of work? Putting people out of business, for example. Walking into a supermarket and you realize there's no cashier, no human interaction, and all of those things, and walking out of the systemic the supermarket again, and it's sort of like putting people out of job. What's your take on? And yes, I'm a strong advocate of the fourth industrial revolution, the deep technologies, but I'm also looking at the side of we are most likely going to put a lot of Africans that are not ready out of work. So what's your thoughts on that?
So my thoughts generally on technology have been, or my yeah, my major thought on on technology is technology basically augments how we live, how we interact with our surroundings. It basically gives us a little bit more space, a little bit more leverage, a little bit more time to do something else, to think about something else, right? So
Yeah,
artificial intelligence and machine learning are not new concepts. These concepts have been there since the 50s, since the 60s. The
yeah,
mathematical models had been built all the way back in that time. The only reason they were not being massively used as we have it right now is due to availability of data, is due to computational resources. Now we have all of those in abundance and more,
yeah,
and so all of those mathematical models that were designed in that era, in that time, can now be used, right? So AI now being the the technology in I would add vogue is just here to try to augment how we relate to things. Admittedly, in every augmentation cycle of technology, a lot of people will lose jobs. But then
yeah,
again, the loss in jobs is not due to any particular bias.
mm,
Now, think about it from the perspective of the person that owns a company. If I'm going to spend um, if I'm going to spend 1 million naira, let's take for example, employing staff, I'm sorry, paying staff every month salaries, and let's just take this is a hypothetical case. So I'm paying 1 million naira in salaries every month for my staff, and you bring an AI model and say this AI model can help reduce how much I get to pay in terms of salaries to maybe 400,000 naira or 500,000 naira, while also at the same time still increasing my profits at the end of the the year. It's now I now get to fight that battle with myself,
yeah.
whether I want to let all these people go away
Go.
for some
Yeah,
reason that a system is doing what they're doing. A system that's going to cost less than them is going to do what they're doing. So every businessman wants to stay on the um, profit making side, cost reduction side, right? And so I have two options. I can either employ more people in the field of that machine to improve my systems further, pay them possibly the same 1 million naira a month,
yeah,
and then get better profits. So I have only changed my workforce, right? I sacked maybe the who can I use? I don't know. I'm not trying to say any profession is less than any other one, but let's just take a case. I fired the law guy in my company, and I
yeah,
hired another software engineer. I fired maybe an operations guy who was manually imputing things in Excel, and hired someone who was going to automatically impute things on dashboards for me, right? So I am not necessarily throwing away jobs. I'm actually just creating newer systems where the workforce is evolving. We have
no,
very clearly seen the COVID-19 scenario that has had to put a lot of businesses on hold, and a lot of businesses, seeing that they would not survive if they were put on hold indefinitely, had to migrate their workforce to the cloud, to the internet.
Mm-hmm.
So a lot of companies are now working from the internet.
It's the cloud
At
as
this
well.
point, yeah,
Yeah.
at this point, you can't even say that it's AI or data science that has
Yeah.
made people lose their jobs.
Mm-hmm.
You would just see that it's the circumstance that has made people lose their jobs. So who is relevant in this time? It's the guy that knows how to use the computer. It's the guy that knows how to code. It's the guy that knows how to analyze data, analyze systems, build business platforms, without necessarily being present in an office. So I would say yes, AI would come. It will take away some jobs, but very quickly it will employ a lot more jobs in the areas that center around how it's being operated, that center around how it's being managed, that center around how it's being improved. So in research, in engineering, in building the systems, in analyzing the systems, there will be a lot of new jobs. And if you go online, you can just Google machine learning jobs, data science jobs, data analysis jobs, software development jobs, software
Mm-hmm.
engineering jobs. You'll see that these jobs are increasing, right? But of course, the other areas that were very dependent on being in a physical office, or very mundane tasks that are being taken over by the new tools, the new methodologies, are going to be put to the shelf. So you owe it to yourself, right, to either go home, get yourself suited for the next workforce,
Mm-hmm. Mm-hmm.
or go home, sit down, and lick your wounds, right?
Yeah.
While waiting for your while taking in your how obsolete you are, right? So
Mm-hmm.
I implore anybody learning many of these systems. Some people think it will take me maybe a year, it will take me 2 years or 10 years, and some people also think that I have to spend so much money that I don't really have. And I tell anybody, as long as you have a mobile phone and you have access to internet, then you can be an AI engineer. You can be a data scientist. You can be anything. You can be a software developer, a software programmer in the shortest possible time: 3 months, 2 months, 3 months, 6 months, longer times just for mastery, right?
Yeah. Mm-hmm.
So I understand. Yes, a lot of people would say, yeah, it's beyond my capacity. Maybe it's not what I'm called out for, and all of that. But the truth of the matter is, if you evaluate, you probably were not just called out to be a tax collector. You weren't called out to possibly just be a librarian sitting
Yeah.
in the office
Mm-hmm.
and issuing out books. Many of
Mm-hmm.
those systems would be automated very shortly, or have already been automated. And so I don't need to go to a physical library. I can just pick books, rent books from a library on the internet, right? So with that now, you owe it to yourself. Everybody owes it to himself to constantly improve on himself, constantly improve on his systems. Even the AI systems we're building, the AI machines we're building, almost get very rapidly obsolete. So
Totally. Totally.
in three
Yeah.
months, in 4 months, in 10 months, data changes, and many of those systems in their learning, or how they were able to learn, they become obsolete in that time, and so have to be retrained,
Mm-hmm.
have to be retrained, have to be retrained. And with that means an AI engineer is always needed, a researcher is always needed to include
Yeah.
new systems, to improve the current systems. Yeah. So you owe it to yourself. If the AI bot is going to be learning too, you have to also learn.
Outlearning.
It's sad, but yeah, that's the reality we're faced with.
Mm. I think it's something that I'd perfectly commend what technology has really done to technologists and engineers. It's made us have there's this thing, Charles Dweck, the psychologist, called the growth mindset and fixed mindset. Technology in itself, based on the rapid revolution of technology, we've had to develop this growth mindset as technologists, because new stocks are coming in, and we're having to keep up and learn, and it's just become part of us to see how we can upskill ourselves to such level. And it's one thing I'll encourage the listeners to do: have group mindset. Anything you can, anything you're probably doing was probably learned by you somewhere or another. It doesn't mean you can't transfer such
Mm.
passion or ability to kind of survive, the survival of the fittest to that. Because here is the survival of the fittest. We're saying it's fourth industrial revolution. Really, it's just the survival of the fittest we are
Yeah.
seeing, and it's just fascinating that once you can upskill yourself, you'll be able to keep up with the ever evolving trend of technology augmenting human intelligence and human capabilities. And that leads us to one thing that you are excited about. So, what are you excited about in the future of machine learning and AI? What's the thing? What's the technology? What's the advancements are you excited about?
So one of the areas I'm excited about is evolutionary learning.
Okay.
Um, Evolutionary learning of machine learning systems simply is machine learning systems taking the best qualities from themselves and self-improving in the next iteration of the model. So, for instance, I learn on a particular image recognition task. Um, the best the best way I'm able to learn as a model, I am able to adapt that and send my best weights to another model
Mm-hmm.
that can use that weight together with its own best weights in another task.
Mm-hmm.
Right. So I am then able to rapidly build systems are able to understand themselves and evolve over time into new learning systems that understand a wide variety of data types, a wide variety of data problems. So evolutionary machine learning is one of the things I'm really excited about. The next is generative adversarial neural
Surely.
networks. Yeah, being able to design new systems, new worlds, new identities from noise data and being able to make them look so real that even AI systems cannot detect, or even advanced systems cannot detect the difference between these created systems
Mm-hmm.
and real life, like real world systems, right? Created images, created videos, created platforms with real life platforms. Advanced systems may not be able to distinguish between those. Recently, there was a challenge on Kaggle to try to build a deepfake recognition system, uh, deepfake detector rather, that tries to detect a fake created image uh, based yeah a fake created image, tries to detect it. So I'm fascinated about that technology too. And yeah, I'm fascinated about what I actually don't know about in AI right now. So admittedly, a lot of the things I know right now, I did not know them 5 years from now,
Mm-hmm.
5 years before now.
Before now.
And I am excited that there could be something else I really don't know about yet in AI that I could possibly also be the one who invents or discovers.
Yeah.
So yeah, I'm excited about that possibility, and it keeps me open to all types of problems, ready to solve all types of problems in AI, and also look at um, different methodologies, read papers, and all of that, and just start thinking things up, and hopefully find some solutions someday.
Yeah, that's a really awesome. And maybe you have some links to, maybe we'll probably do some research on the evolutionary machine learning, because I was struggling to get my wrap my head around that. Maybe we'll leave those in the show notes, and for viewers to have to maybe a blog post or a paper they can refer to for these things you're excited about, which is awesome. And
Sure, I'll send across.
Oh, okay, awesome. So, what's your just to go into the advice to the listeners right now? Of course, some of them might be job seekers. So, what would be your advice for data scientists, ML engineers looking for a data science job in the country or in Africa generally, in developing world countries and so on?
So it's easy to say, oh, I'm looking for an ML engineer role, oh, I'm looking for a data science role, but you always need to understand the dependencies of these roles. You always need to understand the particular skills that you need to excel
Hmm.
in these roles. For
Yeah,
anybody who is starting up in data science right now, I'd say just take some time, make sure you understand your how to you understand how to fetch data, and you understand how to look at data, you understand how to identify patterns in data. Then take a data analysis or analyst role, analyst role. Spend some time. It depends on the industry you find yourself or the company you find yourself. You may be doing a lot of rigorous data analysis, and some places you may just be bearing the title data analyst and not really touching any data. But you need to understand, you need to identify what exactly you will be doing as a data analyst, and spend the time in a company or area or
yeah,
place where you are really, really doing the work, right?
mm,
Where you are really doing the work. I always would tell people spend 6 months, spend 6 months to a year in core analytics. Just spend time there. When you spend time in those kind of in data analysis, it always helps when you come out to the full of data science to understand, oh yeah, it's because this data is the way it is. That's why this model is behaving in this way. Many of the times you see some engineers now, some machine learning engineers and scientists who are just model based scientists.
mm,
And all they do is build the models, and when the models don't respond to what they want or what they think it should, they just get frustrated, like what's going on here, and they think it's by adding more deep learning layers or
yeah,
training for longer, whereas the problem could have just been a data problem. They didn't probably encode it a particular way, or they didn't add one or two more features that could have been added or engineered from the current data set. But if
mm,
you spend time on the analysis of data, different data types, of course, from structured data to image data to text data, depending on the area you want to go into. And you just spend time in analyzing data, building dashboards to understand stuff, right? You will find that once you start building the models, once you start making decisions from data, it will be easier for you to relate with those models. It will be easier for you to relate with the choice of models, the results that will come out from those models, and you'll be able to interpret those to management, because at the end of the day, all we do is to make decisions, so that we tell management, oh, if you go in this direction, this is what will happen. If you do this, this is what should happen. For this case, this is what is happening, right? So if you don't know your data, then you can't make those assumptions, you can make those reports, you can make those statements at the end of the day. You always need to know your data. So spend time on data analysis. Find the data analysis an analyst job. Do it for some time. Find the data analyst, business intelligence,
mm,
or business analyst job. Do it for some time, right? Spend time on it well. And then from there, start migrating. While you're in it, you're migrating gently into understanding data science, ML, all the algorithms, the systems, the methods, the engineering, and finally you can migrate to those kind of roles. If you go online to try to check some of the job descriptions for a machine learning engineer, you would find the majority of his work still relies around understanding data, right? Even though yes,
right,
he builds systems to host and deploy stuff, but majority of his work sits around understanding data. Even the data scientists too. I mean, that's why he will have a whole name, data scientist.
yeah,
You can't be that without an understanding of data.
yeah. Hmm. All right. So I think that that leads to one of the just the last three questions. There. What would be your advice for how they can prepare for an interview? For example, of course, you talked about they looking for a data analyst. Well, of course, it's just going to be classed under the data science arc. So, what would be your advice for how they should prepare for an interview? Suppose you're an engineering manager or a data science team lead trying to hire new data scientists to your team.
Yes. So most hiring managers in data science are always looking out for, first of all, people who can be flexible. So today you may be doing a data analytics task. Tomorrow you may be doing a business analytics task. Tomorrow you may be doing a data engineering task, right? Most hiring managers in data science, especially, are always looking for people who are flexible. You don't need to be all knowledgeable, but you are an ability to be flexible, or thinking that, yeah, this person can be flexible, right? That's one. Two, and uh, a a a research or creative thinking ability, that kind of ability. We're always looking for that kind of person
Mm,
who is ready to challenge what the method you're thinking of.
mm,
So if I come to you and tell you this technique is what I think you should use, I would expect that you can challenge me and say, "Oh,
yeah.
what if we, why don't we, why can't we?"
Mm,
And the challenge is not necessarily trying to discredit what I know or throw me off balance or anything, but basically to just help my thinking go in a different direction too. Um, yeah, that kind of personality. A lot of people are always looking at, a lot of hiring managers, at least I've spoken with, are always looking out for that kind of person. Then someone who doesn't just understand the tool but the methodology.
yeah.
So I get a lot of people come to me and ask me, what tool should I go and learn for data analysis? What tool should I go and learn for programming? What tool should I? And I tell them, don't learn any tool. Don't learn the tool. Learn the method. One of the reasons I am able to code in R, Python, Java, and C++ is because I know the methodology for coding, for thinking like a scientist. And
Yeah.
I just apply those to the language that I find myself using at any point in time for whatever particular task. And um, with that, I can scale to any environment I find myself. If they're using SAS in a company, I don't have a problem because I can simply code in ProSQL. If you're using Python in another environment, I don't have a problem because I can code in Python, right? So science thinking in general. If I'm asked to draw a dashboard, I'm not thinking, oh, I only know how to use Power BI, so
Yeah.
I can't do any other thing if it's not Power BI, right? I know that I'm supposed to just draw graphs. I'm supposed to draw charts. I'm supposed to draw funnels,
Mm-hmm.
or I'm supposed to draw pie charts. So histograms. So if that's the case, then I just need to understand what my data types are, what my data is, and
Yeah.
what is the best representation of that data. And then I move it to a tool, and in a couple of hours, I know the tool and how to use it. Maybe not to um, extremely professional level of, oh yeah, you can do some advanced deep
Yeah.
coding, but all of
Mm-hmm.
that comes with continuous use of the tool you're particularly using. But if you don't know the technique, and you just learned how to use Power BI, then you keep repeating the same things over and over, and you're not deriving insights. You're just plotting things for people,
Yeah.
right? The idea is for you to be able to derive insights.
Mm,
So an understanding of the systems and not necessarily the tool, the methodologies and not necessarily the tools, is what hiring managers are always looking out for. Then, lastly, team play, being a team player.
yeah.
So you get a lot of people who come in and say, "Oh, I can do heaven and earth. I can do this. I can do that. I can do this," and forgetting that the field, data science, involves the data engineer, the machine learning engineer, the data analyst, statistical and mathematical analyst, the software engineer,
Yeah.
possibly, and the business analyst. And all of these people work towards churning out a solution or multiple solutions in
Yeah.
business. If you do not understand how to work with all of these people based on your own field or area, then you always keep feeling maybe more superior or a little bit more, a little bit more superior to all of them, or less superior to all of them, or always feeling like the work depends or sits on you, and you do not understand how each of all these other fields come into play to building a solution. You then are disjoint from the team. You then
Mm.
are disjoint from the company in general, and live basically in your space, right? At some early part in my career, I had made the mistake of feeling like I I could do it all. Yeah, because I could do it all, I needed to do it all. But many of the times, I would see that just a simple suggestion from someone who was even non-data science related could help push me in a direction that would save my time, save resources, lots of resources, and I could get the work done really well. So yeah, you need serious team building skills, an ability to work with various teams, various people, ladies, guys, people way older than you, people way younger than you, people more intelligent than you are. Yep, people more intelligent than you are, people who are more skilled than you are, people who are less skilled than you are,
Mm.
and
Yeah.
yeah, yeah,
Awesome, awesome. I think those are very very vital tips. And talking about thinking in methodologies rather than technology,
yeah,
it's one thing I think people should take note of. Especially that's why it's best you learn the foundations and principles to things rather than just the technology that supports or that builds on top of them, which is
exactly.
quite fascinating. So two rapid fire questions just as we round up. So, but quick question to you: how do you manage to keep track of the latest events in AI, latest happenings? How do you manage to keep track of that?
So I think that's one of my shortcomings. I'm very bad in keeping keeping up with events. But yeah, I've been trying to work on that using an application called Meetup.
Okay.
Meetup is an application that you can basically see um, uh, community meetups in
Yeah.
your area and some out of your area where you can maybe pay a stipend to get to. So yeah, I try to use Meetup to keep track of some of those things. But I try also not to get warped into many of those meetings because of course different you always get different speakers from different industries coming to say different things about different things.
Yeah.
And
Hmm.
yes, sometimes it can help keep your scope and mind open to all of these methodologies, but sometimes also you it it can really throw you off the work you are actually doing, where you need to implement some particular methodologies over and over and over based on the fact that they're the most reliable solutions that can work currently pending maybe future growth. But yeah, so that was my head thinking um, by not attending too many of the meetups, right? Too many meetings and the conferences and all of that in data science. But yeah, if you're able to segment all that information, all that load of stuff, and just keep it away, shelve it based on how I use it based on how you need to, and
Yeah.
you have some money also to be traveling and can request grants, then please by all means
Mhm.
go ahead and
Yeah.
do that because it allows you. One of the good things is it allows you network with a lot of other scientists out there, improving and increasing your chances of moving across different companies, different systems, and even doing some ad hoc projects for different people. Yeah, while not working directly with them or for them. Yeah, I it I would say yes. I have actually benefited from going for meetups and all of that. But yeah, it still comes down to you. Um, based on your needs and how you want to build a career in data science.
Hmm. All right, awesome. Well, that's a great take. So just your final note on this. So, what is one, if you were to tag anything, golden advice? So, what is one golden advice you give to beginners looking to become, world-class machine learning engineers or problem solvers? What's just one golden advice? Maybe in one word, one sentence, one paragraph, something good.
In one word, in one sentence,
Yeah,
learn the math.
learn the math.
Learn
Cool.
the math. Yes, learn the math. Yeah, it's easy for you to build solutions,
Yeah,
right? You can almost today just um, Google how to build an object detection system, and you would see code online to do that,
mm,
and you can just import that code, understand, read it through, and you have an detection system that you can deploy.
yeah,
But then how do you improve an object detection system? You will need to know the math behind what an object detection system is doing. Then you can improve the system, right? So when I say learn the math, I don't mean kill yourself with the math. I
yeah,
mean just understand it enough so that you can always tweak it. You can always play with the algorithms. You can always play with the systems, improve them, and I mean that's the joy in building new systems. That's the joy in building new systems. The fact that when you build your own solution, model solution, you can tell Facebook, you can tell Google, hey, I've got this new solution, I've done this and that and that. And it's based on an understanding of this and that and that and that. And you can explain what you did, and anybody would take, you can take that to the bank, right? You can take that to the bank. So learn the math when it comes to AI engineering.
yeah.
Learn the math, right? I every other thing is secondary.
Yeah,
Every other thing is secondary.
yeah,
Yeah.
yeah. All right. Thank you so much, Evangelist, for your time today. And once again, today's speaker, of course, today's guest on our show today is Evangelist Oden, data and machine learning, machine intelligence engineer at Indichida. And we're so excited you came to share your knowledge. And every other thing about Vangelis will be in the show notes, in the description, or wherever you're, watching this show or listening to this show. And thank you for joining us today. Bye bye, everyone.
Oh, thank you too. Thank you. Bye.